Thank you for joining for this episode of the TechSpective podcast. My guest for this episode is Ammar Alim. So Ammar, if you could introduce yourself, get a little bit of a background on where you're at and what you do.
Thanks, Tony. Good morning to you. Good afternoon, wherever you are. My name is Ammar Alim, and I'm currently I lead the DevSecOps Solutions function within Adobe, supporting a group of engineers who are trying to make security more effective, easy, and delightful. Prior to this role, way back I started from the physical layer in cold data centers, rack and servers, and just following the cloud technology evolution. Moved from a data center setting to virtualization, where I was managing and administrating a VMware farm. From there, followed the cloud again and became a cloud engineer, then a cloud security engineer, then now closer to the user, closer to the software, doing DevSecOps solutions. And who knows, maybe next time we'll move into even closer to the user by doing something with software.
Okay. Well, and it's interesting how that all has evolved and how things kind of keep coming together over time. You know, it's like everything's kind of more tightly aligned. But where I wanted to start things off, though, is a lot of what you do has to do with security, application security, and last year, everyone, the Verizon data breach report is like the Bible of data of data for a lot of people, and last year's showed that a quarter of the successful attacks are actually originating from the application layer. So I'm curious, from what you see, why do you think that is?
Very good question. So there are many reasons for that, but to name a couple that come to mind is that the application is the front door, is what available, publicly reachable. Anyone can find your URL and they can scan it and find vulnerabilities very easily, and they start from there. The second thing is that most of to enable innovation in rapid software development, we have to use third-party tools or libraries, and those have vulnerabilities. So this is the easiest. You get high ROI on your effort when you start there. So,
okay,
just to name a couple.
It makes sense, and I've had a couple conversations in recent months about things like that, like about how you look at something like Log4j, and when that hits, it's real easy to say, oh yes, I use Apache, I use Log4j, I should go look at that. The challenge is most of the implementations of that vulnerable code probably exist outside of actual Log4j. It's other people who are using the same code module, the code snippet or whatever, but may not actually realize they're using Log4j.
Exactly. That's and it's across, if you think about Node.js, there are hundreds and if sometimes thousands of, depending on the app, thousands of libraries, and you really don't know what you're using sometimes. It's really difficult.
Okay. So in you're doing DevSecOps, with Adobe. What is your approach for addressing the issue? Like, how do you deal with the fact that that applications are your sort of your Achilles heel?
Fantastic question. So at Adobe, I got lucky where I am working for, quote unquote, the founder of DevSecOps.org, Shannon Leeds. I'm pretty sure your viewers are kind of familiar with that name. So she laid the foundation of how you go about securing software. And I'm very aligned with her approach, which is pretty much making security very accessible for engineering teams. Eliminate fear, eliminate guesswork, make it very simple, very approachable. Engineering teams have a lot of things to do. There's so many things to learn and features to ship for a company like Adobe that is really innovative. We have to make security very accessible to them in the form of solutions, tooling, guidance, and whatever it takes just to make that barrier to entry very low as far as adapting advanced security solutions.
Okay. Well, one of the things that I've noticed for a long time, I've talked about frequently is, the thing, zero days get a lot of attention. They make headlines. Everyone's like, oh my God, there's a 0 day. But the empirical evidence suggests that like that's not really where you're weak. Yes, that's a problem. Like, yes, attackers, threat actors have arsenals of 0 days that you don't know about yet that they can use to get in and those kind of things. But that's almost like the I don't know, that's like the dramatic James Bond version of cybersecurity, whereas the reality is most attacks are just using already existing known things. They're following standard patterns. They're not special. It's not that it's a sophisticated nation state. It's just that you have misconfigured or poor security or you have open vulnerabilities that have been known about for years or whatever. And I think that the kind of the foundation of the standard approach to cybersecurity is the sort of vulnerability management and patch management. I'm going to scan constantly for vulnerabilities, and then I'm going to go patch them. And it seems like that's on the one hand, if you could do that, if you could patch all the vulnerabilities, maybe that would be great. But it's impractical to think that you can patch all the vulnerabilities, first of all. And second of all, it seems like a lot of organizations struggle with where to start with that, because you don't just go alphabetically, you don't just go numerically. Like, you need to have some sort of a context prioritization of like, well, why, which vulnerability matters the most, and that's a function of a lot of things that aren't just the CV score and stuff. It's like that's one factor. One factor is, yes, someone arbitrarily says this is a critical vulnerability, but it's like, okay, but what other mitigations do you have in place, and what system or server does that vulnerability even exist in? And so all of that's a very long way to say that yes, vulnerability management and patch management are useful, especially if they could be done fully. But since they can't, it seems like maybe that's not the place that you should focus. Like, you shouldn't hang all of your cybersecurity on your ability to patch vulnerabilities.
I 100% agree. And I could talk about this topic. This could actually be like a separate podcast where we talk about vulnerability management. It's what in previous teams that I work at, and this is still what a lot of companies struggle with, is that we bring a tool like, there's many good tools, and I'm not going to name any of them, but you get a tool, you scan, you have a big report, and the standard way is that you give that report to a developer and you tell them, hey, you have vulnerabilities, could you address those vulnerabilities? That's very impractical, and they have a big backlog. Now you double the size of work that they have to do. And I think the better approach here is, if you're going to do vulnerability management, and you should, is to really think about having a function that really just sit and give developers only actionable data. Like if it's not actionable, do not waste your time. Like, first of all, is it exploitable? Is there's an exploitable intelligence out there that suggests that someone was able to exploit this? Second, is it like front facing, or is it like like a tool that no user will be accessing? It's private. It's about behind a VPN or something like that. So when you kind of do a careful threat modeling, and you understand your apps, you understand your attackers, you could probably give them something more actionable than just, hey, here's a report. And to go back to your people worrying about like really advanced techniques, that's not the case. Like if you look at the popular breaches over the last 3 years, it's usually an open S3 bucket, like something as simple as that.
Right.
And
right.
yeah,
Zombie VPN account.
exactly.
Well, and so it seems like like I know with some of the stuff that you guys are doing, that I feel like it addresses kind of both aspects of that, because there are 0 days or whatever, but it's like, well, if you take the focus from I need to identify these vulnerabilities and fix them to instead saying I need to understand the way threat actors work and look for the telltale signs. I need to look for, anomalous behaviors. I need to look for, there are things that, that maybe the average person wouldn't recognize, but that a cybersecurity person would look and go, oh, that's shady. Or even things that are not in and of themselves shady, but when you put them together in the bigger picture, when you say, okay, well, it's okay for that to do that, but it's doing that and then jumping over there, and okay, now that's seeming suspicious, and so it seems like if you approach it from that angle, I feel like you are better able to defend both against known threats and unknown threats, because you're not relying on your ability to identify the vulnerability. You're like, you don't have to know, okay, I know exactly what vulnerability they're going after, or I know exactly what exploit they're using. It's just recognizing, hey, there's some suspicious stuff going on.
Yep. So this is a great segue to the conversation about the main topic of today's kind of podcast. I do some soccer coaching, like here in local high school, and one of the things that we usually tell students or soccer players that you either chasing the game or the game is chasing you. This is very applicable here in cybersecurity, where if you're waiting for attacker for a 0 day and then trying to respond to that 0 day, you're reactive. You really, there's vulnerability, and then we're going to have all hands on deck, and we're going to do some patching. If we are using a WAF, maybe we'll, deploy a virtual patch until developers get to really patch that vulnerability. But what if you kind of spend some time trying to understand your attackers, collecting as much intelligence, as much data you can to kind of stay ahead of them always? You have the data based on, intelligence. But for now, let's maybe get into the concept of adversary-aware applications. This is a concept where, you have your traditional app and how do they react to common attacks, right? You have a traditional app, like, hey, TechSpective.com, for example. An attacker is attempting to conduct a SQL injection attack. What usually happens is that the application is going to evaluate if it's a legit request, Or if it matches some of like it's if it's not legit, it's not the expected input, the application will just block it, right? The difference, an adversary aware application is an application that not only does that, but also capture as much information about that request. So, OS, browser, where you're coming from, what you're trying to do. And it not only take an allow list approach, it's also take another approach, which is a block list kind of approach where we say, if it has a script tag, maybe this is like a cross-site scripting attack, and we're going to take that and we're going to record it. If it has some SQL injection code, we are going to label that as a SQL injection attack. We're not just going to block it and be silent about it. We're going to note lots of other metadata about that request and store it. And we're going to see how many attempts we got, where in the application, and now you have some data about that user or attacker who's trying to do something. And you could, over time, you could tell a story about, for Adobe products, you have Photoshop, you have, Frame, you have many products. You could tell a story about that attacker. Who was targeting Photoshop and not targeting Frame? Who was targeting product A versus product P? And you could go back to developers and kind of give them that data, and that will feed into secure coding practices, which is the really important thing here. It's not about the tools that kind of detect things after the fact. It's about all the tools that can detect things ahead of time. And if we kind of speak about like the phases of an attack, attackers usually start with something like nmap. All right, I'm going to throw things at you, trying to know like what kind of errors I get. This is the first phase, right? The second phase is, hey, I think they have a SQL database based on the errors that I'm getting. They have this, they have that. They kind of profile the application and they understand what technologies that you are using, and they will develop exploits targeting those technologies and weaknesses. This is the second phase, exploit development. The last phase is actually exploit. And we usually detect things after the fact, after the exploit has happened. For example, if they're attempting to create a SQL user, the application will note that, hey, someone just created an admin SQL user, but it's done. The application, an application aware is going to detect things in the first phase, like the beginning when they get errors, errors are being generated and there's so much noise. We try to label that ahead of time and take some action.
Okay. Yeah, the recognizing like some of the behaviors, it reminds me like so back in the day when I was doing network admin stuff and working like in the trenches, we would look at logs and say, okay, well we have all these like failed login attempts, and someone would be like, oh well, we need to look at that. That's a concern. And as I looked at it, I said, wait a minute, that's actually not the concern. Like, we logged them as failed attempts. Like, obviously we stopped them. We have a record of that. What we need to know is which ones didn't we catch, and that's the hard part. It's like having a log of all the ones you blocked doesn't really help you. You need to know which ones didn't you block. So a lot of what you are describing, and this happens a lot, and especially I think happens a lot. It's happening a lot more right now. Is we have all these different tools and solutions and products in cybersecurity, and the Venn diagram has a lot of overlap to it. There's a lot of tools. Like, we're all trying to solve the same problems in slightly different ways. Someone comes along and says, oh, well, I think I have a little bit better way to do that. but so the approach that you describe for, having an adversary aware application or whatever, it sounds to me at face value like it's sort of part threat intelligence or threat hunting and part user behavior analytics. Like you're partly looking at, okay, well, how much threat intelligence do I have about, how potential attackers work, and what kind of what's going on in the world, like things I should maybe be looking for, and then also, what do I know is normal, and how is what I'm seeing different from that? So I guess first of all, I would say, do you think that's a fair assessment? And second of all, how would you say the adversary aware approach is similar or different than, say, threat hunting and user analytics or behavioral analytics?
This is a very good question. So when we first started thinking about this concept, we thought about all of these, all right, threat intelligence, or tools like EDR, web application firewalls. Where's the gap? Because if we're going to promote a new concept or a new approach, where are the gaps and what we need to do to fill those gaps? Because we do not want to reinvent the wheel. This approach is, think of it as a runtime solution, and it's application specific. Like it's aware of the business logic. If we go and buy a WAF, the WAF will, it's a generic product that is designed to address or to support any use, like many use cases. It doesn't really care about your specific product. It doesn't care if it's a photo processing application or a video processing application or a financial application. It's just going to say, if I see a SQL injection attempt, I am going to block it, right? This approach is a little similar to what the WAF does, but it's more the false positives are really low because the developer is aware of how they built the application. They know what's normal and what's not normal for that application. And developers are really close to their code. So you piggyback on that because they live there, they are coding every day. They could just add few line of codes that says, this is expected, let it pass. This is not expected based on my business logic, and I want you to do X, Y, and Z and take the following action. There are many things that we could do on top of this. For example, we notice an attack, and again, to just reiterate where this tool sits. It sits at the first, the discovery layer, like using Nmap, generating so many errors, nobody noticing, right? Like if I were to give you an example using your network login solutions, if you go and hire some third-party pen testing tool, you don't tell anyone, they come, they start hacking, and they start pen testing, you're usually gonna catch them by those networking alerts. Like you're gonna, hey, we have pen testers, we see these errors, can somebody allow this, or can somebody do X, Y, Z about it? You're not gonna notice any noise as far as the app itself. They may come, they start hacking, you're not gonna notice anything unless you see that report. This is what we're trying to change. At the discovery layer, when they come, when they start scanning, generating some like SQL errors, trying to understand your application, here is what we try to label you, try to profile the attacker, and make some decisions. Threat intelligence, like you're anticipating what the attacker is going to do, but it's not based on your actual application. It's just based on generic, industry feed or generic data that is out there about what attackers generally do. But this approach will actually allow you to know who's that attacker, why they're coming after you, like what is the motive, what time, what country. You will get the opportunity to really understand the adversary and plan to combat them according to actual data from your application.
Okay. So in previous roles, I've worked closely with an MDR company. I've worked closely with an XDR company. Although right now I feel like everyone thinks they're an XDR company. But the concept sounds similar to me in that just following that evolution from sort of antivirus software to EDR was a similar logic of, hey, instead of having to capture all of the malware variants and reverse engineer them to create signature files and then scan everything that comes in against our database of signature files so we can figure out what's what if we just looked for things that look like malicious behavior and detect that and then raise an alert and so people can respond to it. That's kind of the basis of EDR. And then we've just kind of extended that to, okay, well, what if we did the whole network? It seems like your approach is like, okay, well, what if we went the other way? What if we went micro instead of macro? And we said, what if we do detection and response at the application level?
That's true. And also that gives you more flexibility as far as what actions to take. For example, one of the things that we are exploring is that, all right, we detected this as an attack. We labeled it as an attack. There's this attack, multiple IPs, multiple users from this country. We have a label now. We understand this is an attack. We could redirect you to another version of this application. You assuming that you're still there, redirect to like a staging environment, and we let you attack. Do you think? Because it's within the application logic.
Right.
You think you are attacking us. We collect as much data as we can. We send that data to our adversarial intelligence functions that they actually gather and know more about attackers by looking at the logs, what kind of strings they are using, what kind of commands they are running, and so on. So that gives you more flexibility as far as what to do next. And also, again, it's like developers are really receptive to modifying their code to do something. I am like you have that bride, that connection to your code. If you go to a developer and give some advice to make the code better, they will code it. They will implement it instead of bringing many tools, right? And each tool is addressing this one thing, and you have to send all the log to a SIM. We still do that. Don't get me wrong. Like you still need with security, the more the better. But as long as you could, reduce the noise and make some provide some actionable data. This approach is going to supplement EDR, WAF, like container security tooling. Think of it as a way to reduce noise and get some actionable insights about your attackers and attacks.
Okay, which is a good segue because my next thought was, was kind of like, okay, but if I'm doing detection and response at the application level, which is like, that's at the front end, at the where the rubber meets the road, so to speak. Do I still need EDR? Do I still need XDR? If I'm already doing detection and response at this lower level, and so part of my thought was, okay, well, if I have application aware, if I have adversary aware applications, do I even need those things, or does it negate them? But then, based on what you just said and kind of augmenting it and kind of working together, it seems like maybe instead of negating it, it's more like figuring out how to integrate it, figuring out how to make sure that they talk to each other in a way that is useful for you from a holistic perspective. Because one of the problems is like a lot of tools are great at what they do. Like your EDR might be great, your firewall might be great, your SIM might be great. All those things might be great in and of themselves. The problem is that from a cybersecurity perspective, you're not trying to accomplish what each one of those tools does. You're trying to accomplish a bigger picture that requires all of those tools And so you need them to be able to talk to each other, talk in the same language, and present to you as the IT security lead, as the CISO, as the whatever. I need it presented to me as a holistic, this is what my security posture looks like.
Exactly. So, in cybersecurity, there is not one tool that would do it all. No one solution that can do it all, right? Like you have to approach it from, tech stack perspective. For containers, I need this tool. For AWS layer, I need that tool. Application layer, I need like 5 tools. And the problem and the main thing is try to get the data that you can use to address security issues, right? Solutions like this will only supplement tools like WAF and EDR. And I had this conversation with a colleague of mine where he said, when I ran this idea by him last year, he said, where do I start? Like, how can I start? Like, assume I don't have anything, right? I suggested like, hey, start with a web application firewall. Like it's a great tool to start with. Like you're gonna know how many SQL injection attempts. Yeah, there may be some false positives, but it's gonna give you a good understanding of who's attacking you, what's the user agent, what's the IP address, and so on.
Right.
Then you can go more granular and business logic specific by deploying something like this that is really like homegrown, addresses your applications, your customers, your attackers, right? And there are also some open source initiatives that are trying to address this problem right now. One of them is a project called App Sensor by the OAups. And it's a little heavy, but they provide some good examples, some code samples that you could take them and use them as a starting point.
Okay. So the concept, adversary aware, applications, digital products, whatever. The concept is, something you guys have come up with, in Adobe, something you're personally working on. Is it, do you foresee it being possible to be a future product category? Like I would go out and I'd buy EDR and I'd buy some ADR, for my application detection and response, or is it something that just needs to be lower than that? Like it really is kind of part of the DevSecOps process. It's part of the development cycle. It's not like a product you can add on after the fact. It's something that's got to be coded into the application itself.
Very, very good question. I thought about that and I started looking at if there are tools that kind of address this problem currently. And there are few, like one tool out of Datadog, I think, but they are still not going to understand that business logic. They do a pretty good job. You could start with them for sure. But they are not going to address this problem. I think that we're going to see some products soon. I'm seeing some startups exploring this idea here and there. But I think you're going to still need to have something in-house. Like developers who understand their business logic need to implement some of this.
It almost seems like instead of it being like a product I buy and install and it just kind of sits on my network and watches things or whatever, or sits on my endpoint and watches things, it seems like it would fit more in the shift left Veracode, like the AppSec, offerings, where it's like, okay, we're going to make this part of our, as we scan your code and tell you what's wrong with it, this is part of what we're going to build into it. Like maybe that's the approach, is it becomes part of AppSec tooling.
Exactly. And you could think about like a good example would be, think about like how developers do like error handling. As you're building your application, you're going to catch some exceptions. You're going to send those somewhere, and you're gonna, your SRE team are going to react based on that data. It's very targeted. CPU, RAM utilization, and stuff like that, right? There are some tools that kind of do that, but there are some things you have to catch those errors yourself. There's no tool is going to do that. This is exactly the same thing. Just think about it from a security perspective. You started coding. All right, here, this function handle authentication, right? I want to detect credential stuffing attacks, right? For example, if you see, I only accept 15 character passwords. If I see 16, I want to log that. And I'm going to log all things related to that. And you can go like to SQL injection, like all common attacks, you could do the same thing.
Okay. Interesting. Well, I think that it sounds like I agree that it sounds like a good approach, of being able to say, just going back to the very beginning, going back to the idea of, even if I could know all of the vulnerabilities, it's like the just the process of constantly vulnerability scanning and then trying to prioritize and address the patching and mitigation that goes with that is just it's daunting for any size organization, and for larger organizations it's just it's Sisyphean, just you're never going to get there. So it makes sense to try to build that into the product at the application level, to be able to say, okay, I recognize that this is suspicious or malicious. And I really like the part that you mentioned kind of later on towards the end, of not just taking that and saying, oh, I recognize that this is suspicious activity. I'm going to I'm just going to shut this down. But instead, sort of honeypotting them, sort of like being like, all right, well, you know what, you go ahead and play. Let's see let's see what you do. Because you learn a lot from that. So instead, it's like, if it's like I see that happen. It comes up all the time. I'm gonna go back to my James Bond references. It comes up all the time in like thriller type movies and books or whatever, where it's like, well, if you just end it now you've got nothing. You have no trail to follow. Like if you killed the bad guy, well, now you can't even ask him like who was he working for or whatever. It's like you need to kind of follow it along and see where it goes so you can learn from it.
Exactly. Like if I were to summarize all of this, yes, all tools will tell you something about the attacker, but those tools are not like specific to you, to your use case, to your business logic, to your applications, to your users. You're not going to know about who is targeting you unless you intentionally and deliberately go and decide what to log about that attacker. Like an analogy, like there is some nutrition advice that is given to everyone. Avoid junk food, avoid exercise, and you're going to get some benefit. But your genes matter, right? Like if you're from this region, maybe you're allergic to X. If you from that region, like it's not as like the general nutrition advice is not as specific to you.
Right.
And you have to explore that and figure out what works for you and what doesn't.
All right. Well, I appreciate you taking the time. It was an interesting conversation. So like I said, I like the implications of what how that could help improve security. So yeah, definitely thank you for taking the time, and maybe at some point in the future we'll schedule another podcast and we can just spend an hour on vulnerability management and
looking forward to it.
Why it's an overwhelming and daunting experience.
Exactly. Thank you so much, and thank you for having us. Thank you.
I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow at TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.